Okay, some of these story problems can be kind of confusing, so we're going to go over a lot of them in this video. This is a contractor is paid $95,000 for the construction of a building. The contractor's expenses are $81,700 for expenses. The percent profit, what percent profit is made on the job? So you go to your ratio. So it's percent, 100%, but instead of is of, you got to go part over base, okay? The base is the amount paid. Now, I helped you out on this video. The base is the amount you're paid. The part is your profit. What we're trying to figure out is a percent profit, so that's why that matches up with profit, and that's the amount paid. So question mark for that. And then what's the amount you got paid, okay? The amount you got paid was $95,000. Now you got to read pretty diligently here. How much profit, how much actual dollars of profit did he make? You don't really know that. That is not your profit. Expenses is like the opposite of profit, okay? What you need to do to figure out this cat's profit is take what he was paid minus the expenses that he incurred. If you took business math, that should be obvious, okay? You take what you're paid minus the expenses you had to pay out of your own pocket to get the job done. That's how much profit you got. $13,300. Then you cross multiply and divide, you get 14. So 14% is your answer. Okay, next one. A lab technician usually prepares 245 milliliters of a solution. The technician prepares a new solution that is 35.75 more than usually prepared. How many milliliters of new solution are prepared? Okay, so percent over 100%. Now it's part base. So the base is the usual prepared. Just put usual. That's how many ml usually, and I put the label. This is how many milliliters actual. Okay, what are we trying to figure out? How many milliliters of new solution are prepared? That means that's the actual amount, okay? Well, they usually prepare 245. That's the usual. Now the percent, you got to be careful. It says more. So when I circle words like that, that means you're not going to use actual 35.75. You're going to add 100 to that, so it's 134.75, okay? Because it's that much more than that, the usual prepared. Whatever this is 34.75% more, so we add. Now you cross multiply and divide, you're going to get 330 point and then a decimal, so just round it to nearest 100. 330.14. Okay, next one. A printer has 782 reams of paper in stock at the beginning of the month. At the end of 2 weeks, 60% of the reams in stock are used. That means they're gone. How many reams are remaining after 2 weeks? Okay. Okay, so part over base. So the part is your total reams. That's how many you begin with or whatever. The base. Oh, I got these mixed up. My bad. Okay. Put part, base. Yeah, base is total reams. And the part is the reams remaining. There's another problem I messed up on that too. Okay, so it says how many reams are remaining. Okay, so I'm not going to know that. Now the percent I'm actually given, it's 60%, but those are used. Those aren't how many are remaining. So used means I would take 100 minus 60, and that's going to be my percent. Okay, so the total reams we have 782, and then we're going to find how many reams were remaining. 40% of them remained. I got that set up. Now, how many was that actual? So 40 times 782 divided by 100. Again, fix those. That's 312.8. Just round it to 313. You can round however many you want. So that's how many reams were remaining. Or you could just find 60% of take that times 0.60 and subtract the amount from that. It's up to you. Okay, there are other ways to do these problems. Okay, I messed up on the next one. Additional should not be circled, sorry. A welder estimates at 125 meters, this page here is kind of a pain in the butt, that whole page. A welder estimates that 125 meters of channel iron are required for a job. Channel iron is ordered including an additional 20% of the estimated job allowance for scrap and waste. 175 meters of channel iron are used for the job. That amount is what percent more than what was estimated? So the part and the base. So the part is how many were actual used. So how many meters were actually used. And down here we got how many meters were estimated. Okay, remember the base goes on bottom. Okay, now here's what makes this confusing. A lot of people will put 20% right there. No, 20% is not the meters that were actually used. Okay, that's how many they ordered. So you don't use 20%. If you read the problem, it says the amount's what percent more than what was estimated. So again, that percent cannot go here because it's not the meters that were actually used for the job. How many meters were actually used? Well, it says 175 are used for the job, so that's actually used. How many meters did they estimate? Well, they estimated 125, but then they knew they had to add 20%, okay? So down here I put 125, but that has to be multiplied by 1.20, okay? Here's why it's 1.20. Because it times 1 because they used the 125. Okay, and then 0.20 because they had to use 20% of that. So I take 175 times 1.20. Okay, 210 was how many they estimate, or wait a second here. That's 125, my bad. 125 times 1.20 is 150, okay? So they estimated it at 150. So now we know the meters that were used, the meters that were estimated, okay? Again, that waste, you take the estimated amount times 1 point and then whatever the percent was. Okay, so cross multiply and divide. Okay, 117%. Now, that's not quite the question though. The question is the amount is what percent more than what was estimated. How many more percent is 117, the actual used amount, than what they estimated, which is 100, okay? Well, the difference between them is 17, so the answer is 17%. So that's a tough one, okay? Okay, the day shift of a manufacturing firm produces 6% defective rate of 1,638 pieces. The night shift produces a 4.5% defective rate of 1,454 pieces. How many more acceptable pieces are produced by the day shift than by the night shift? Well, you're going to have to set up two separate proportions for the day shift and the night shift, okay? So 100%, 100%. Now the part and the base, okay? The part is the part that was defective, and that's for both of them. The bottom is how many pieces total there are. So total, that's your base. Okay, now, so defective. The rate is 6%. Now it's 1,638 is the total number of pieces. Okay, and then for our night shift, the defective percent is 4.5. 1,454 is the total number of pieces. Okay, so you cross multiply and divide, and that's going to get your defective rate. That's going to get how many of the pieces were found defective. 98, just put 98. Okay. That's going to be, just put that as 65 or 66. Okay. Now, you got to look at the question that's being asked. You now have everything you need to know, but it says how many more acceptable pieces are produced by the day shift than the night shift. Acceptable pieces is the opposite of defective, okay? So you don't just go with these. Here's what you need to do. Think about it. They produced 1,638 total pieces. 98 were defective. Well, then the rest of them are acceptable to be sold. So subtract these, and that finds out how many were acceptable. So 1,540 were acceptable from that shift. Now, same thing here. You have that many total pieces. You found how many were defective because the percents were the defective rates. But now we want the acceptable, which I find just by subtracting. Okay, 1, 3, 8, 9. And you just subtract, 'cause you're finding how the question how many more means the difference. 151, okay? Okay, next one. A resistor is rated at 2,500 ohms with a tolerance of 6% above that amount or 6% below that amount. That's what that means. Tolerance is the amount of variation given for a given quantity. The resistor is checked and found to have an actual resistance of 2,320 ohms. By how many ohms is a resistor below the acceptable resistance low limit? Okay. So you got 100%. We're going to use 6%. And the base is your and the part is your variation, the ohms of variation. That means how many ohms below or above, okay? And then the base is the ohms that were rated, okay? So we're rated at 2,500 ohms, so that belongs here. And then I'm going to cross multiply and divide to figure out how many ohms of variation that could be. So it can go 150, it can go 150 ohms above that amount or 150 ohms below that amount. Well, obviously that's below the amount, the 2,320. Okay, so you got to think that's not the answer. That's just how many ohms you can be under. Now they measured this, that's how many ohms it had. Okay, is that acceptable? Well, that's under the 2,500. What's the acceptable limit? Well, to find the acceptable limit, we have to take 2,500, and it can be below by at most 150. So that's 2,350. Well, that's under that amount, so that's not acceptable. So you find the difference between these two. So that minus that is going to be 30. 30 ohms. Okay, next one. 42 grams of a certain breakfast cereal provide 20% of the U.S. recommended daily allowance of vitamin D. Find the number of grams of cereal required to provide 90% of the recommended daily allowance of vitamin D. Again, there are two kind of percentages we have to deal with, so I set up two proportions. Okay, and I'm given two percentages, 20% and 90%. Okay, now here's the base and the part. Okay, the part, 20%, that is vitamin D grams. Okay. Or wait a second here, do I have this mixed up? These are messed up again. Okay. Part, base. Okay. Okay, remember the part's on top, the base on the bottom. Okay, the part is the grams of vitamin D coming from the cereal. So the coming 42 grams of a certain breakfast cereal. So the 42 is coming from the cereal. That's your part. Now cross multiply and divide, and that will find how many total grams we're supposed to be taking. Okay, so 100 times 42 divided by 20. So you're supposed to have 210 grams of vitamin D in the day. 42 grams come from the cereal. Okay. Now it asks 90%. Find how many grams of cereal I'd need to take, because I know 42 grams will give me 20%. How many grams do you have to get 90% of the recommended daily allowance? Well, this 210 right here, that's what they recommend you have in a day. Okay, I just figured that out from the previous proportion. So now to find out how many grams of cereal I'd have to eat in the morning to get 90% of what they say, I take 90 times 210 divided by 100, 189. So that's your answer, okay? You'd have to take 189 grams of your cereal to get, because you'd have to find out first. I figured out the 210, the recommended amount of what they say I take. Then I put 210 down here. Once I got that, then I can find anything with the percent. Again, that page is wicked. Okay, now it gets a lot easier. Okay, I screwed this one up before we get to it. So, base part. Okay, a garment requires 3.5 yards of material. If a quarter of material is waste, what percent of the amount's waste? Okay, so obviously it says what percent is waste. Okay, so the part is my waste. The bottom is the required amount. Requirements 3.5. The waste is 1/4. Cross multiply and divide. You get 7 1/7%. Okay, a casting when first poured is 17.875 centimeters long. Then it shrinks by 0.188 centimeters as it cools. What's the percent shrinkage? So we're finding the percent shrinkage. So the part is the centimeters of shrinkage. You can abbreviate if you want. And the base is the centimeters of length when they first produce it. Okay, so when they first pour it, it's 17.875. The shrinkage is 0.188. Cross multiply divide 1.05. Okay, a small manufacturing plant employs 130 persons. On certain days, 60 employees are absent. What percent of the total numbers of employees are absent? Okay, so again, we don't know the percent. That's what we're trying to figure out. Okay, they want to know what percent are absent. So part that's absent over the employees total. And those are there to help you, as long as your idiot teacher can write them correctly. I wrote through those awful fast. Okay, well, we know how many are absent. We know how many employees there are. Cross multiply and divide, you got it. It'd be 12.31. Okay, 97 acres out of 385 acres of timber are cut. What percent of the acres are cut? Okay. Again, we don't have our percent. They want to know what percent is cut. So the part is the acres that were cut. The base is the acres that were total. Okay, now when it says 95 of, when it says a certain amount of a certain amount, then the amount of is your base, 385. It's like the of right there. 97 is the amount that they cut it. Cross multiply and divide, you get 25.2. Okay, a certain automobile cooling system has a capacity of 6 gallons. To give protection, 40% of the cooling system capacity must be antifreeze. How many gallons of antifreeze should be used? Now, you're not finding the percent. You're finding how many gallons of antifreeze should be used. Well, you know that you have 40%, and it must be antifreeze. So you got the part is your gallons of antifreeze. AF. The bottom is the gallons in the cooling system. So what do we know? Well, we know we have 6 gallons. That's for the cooling system. Okay, how much is antifreeze? Cross multiply and divide, you get 2.4. Okay, a machine operator completes a job in 80% of the estimated time. The estimated time is 8.5 hours. How long does a job actually take? Okay, so the 80% is, the part is the hours it actually took. So hours actual. And the by base is of the estimated time, so it's the hours of the estimated time. So we know we got 8.5, that's the estimated time. We're finding how much it actually took. Cross multiply and divide 6 4/5. Okay, an electrical circuit, a certain resistor takes 26% of the total voltage. The total voltage is 115 volts. Find how many volts are taken by the resistor. Okay, again, you're not finding the percent, so you must have the percent, 26%. Okay, of the total voltage, so the base is your total volts. And the part is the volts taken by the resistor. Of those total volts, how much is taken by the resistor? You can abbreviate, or you can just look here and look. Okay, it says the total voltage is 115. You're trying to find how many are taken by the resistor. So you cross multiply and divide, you get 29.9 or 30. Okay, it is estimated that 30% of an apple harvest is spoiled by an early frost. Before the frost, the expected was 3,800 bushels. How many bushels will be spoiled? Okay, you're not finding the percent, so that means the percent they must give us. Okay, and it says of an apple harvest, the base is a total bushels before the frost. Okay, bushels before the frost. Okay, and then the part up top is spoiled by the frost. And we're trying to figure out how many were spoiled, so we got to know the bushels total, which is 3,800. Cross multiply and divide, you get 1,406 were spoiled. Okay, on a production run, 6.5% of the units manufactured are rejected. If 140 are rejected, how many units are produced? Okay, so you have your percentage. Okay, of the units manufactured, so the base is units manufactured. The part is the units that were rejected. Okay, 140 units were rejected, so how many were manufactured? Manufacture and produce mean the same thing. You got to be a little bit smart knowing like what the words are. Cross multiply and divide that, you get 2,154. Okay, this year's earnings of a company are 140% of last year's earnings. Okay, the company earned $910,000 this year. How much did the company earn last year? So we have 140% of last year's earnings. So the base is last year. And the part is this year. Sometimes the part can be higher than the base. This is going to be one of those instances. It says of last year, so of the base last year. Okay, that's this year, so cross multiply and divide, you get $650,000. Okay, during a sale, 32.8% of a retailer's fabric stock is sold. Okay, of his stock, so the base is the money he has of stock is sold. The part is how much was sold. The income received from the sale is $8,765. What's the total retail value of the complete stock? Okay, so we have 32.8 of the fabric stock. So again, the base is the money they have in stock. Okay, invested in. The part is the money of that they sold. So it says, what's the total retail value of the complete stock? So this is what I'm finding. Okay, the income received from the sale. Sale and sold are synonyms. They're just a different way to say it. So that's how much they sold. So you cross multiply and divide, you get $26,723. Okay, then our last one. With use, a 12-volt battery loses 5.6 ampere hours, which is 18% of its capacity. How many ampere hours of capacity did the battery originally have? So you're not finding the percent, so you're going to use 18-ish or percent. Now the base is the capacity. That's how many of the ampere hours are in the whole thing, okay? The part is how many ampere hours were lost. Well, 5.6 is how many they lost, and that accounts for 18%. Now, what was the capacity originally? That would go with 100. Cross multiply and divide, you get 31.1 capacity.